Okay, so I wanted to go over this Frappy since there's some key things that we want to kind of make sure we understand here. So this one right here, this is just, you're just doing a four-step process. That testing whether the bead amount is different, so it's a not equal to. There's where I defined. It says assume conditions for inference are met, so you don't need to go through all the checking. You notice here I still state the procedure name, but it does say assume conditions are met, so I'm fine there. And I go through and carry this out. Okay, this part down here, again, I'm assuming, as always, that you've read this and tried to do this on your own, because that's how we learn, is by doing things and struggling, making mistakes, and then learning from our mistakes. So you've already read this problem. So what they're doing here is they're testing the standard deviations. So it's like I'm testing that the true standard deviation is 0.05, and the alternative, I want to know if the standard deviation is greater than that. So back up here, is it greater than the 0.05 ounces? So that's what I'm trying to figure out here, okay? Then what we find out is this is what we observe from the sample. So they take samples, they took a sample of 4 up here, and that's what they observed. That was the sample standard deviation. So then what this is it's doing a simulation. So it took 300 samples of size 4, and it found the SX for each of those samples. So each of these dots here represent a different SX. This is just like what we did when we did the Reese's Pieces. So each of everybody had a cup. Within that cup, you all had a proportion of oranges, and when we put all those pea hats together. So this is doing the same thing, but using a software as opposed to like simulating it by hand. So in order for me to figure out the p-value here, what I am doing is I'm taking this value here and I'm trying to find the likelihood of observing that value or something more extreme. And I say more extreme, and this way my more extreme is going to be greater than. So this is probably about where that 0.085 is. So that value or something higher. If I do that math there, remember there's 300 samples, so 300 of these dots. 12 divided by that gives me 0.04. So let's say I am using the alpha of 0.05. So in this case, 0.04 would be less than 0.05, so I would reject HO, and I would conclude that the standard deviation is greater than 0.05. So I said here the simulation provides evidence that the standard deviation does exceed 0.05 fluid ounces. According to the simulation, if the true value were this, there is only a 0.04 chance of obtaining a sample standard deviation of 0.085 or higher. This is because I said already if the true value, so this is less than an acceptable, which is up here. So since it's unlikely for me to observe that value, I would say that something is wrong, and then therefore they should stop production and check it. Okay. All right, on the back, probably not too much to say here about the back. You should have been okay with part A. On the back, just make sure again that you still know the difference between those type 1 and type 2 errors, and you can describe them when it says just in the context of the situation. So what are the errors for this situation? So you want the context. And then what are the consequences in the context? So you want to make sure you can do that. Again, so I wrote it a little differently here, but you can always say, they believe that it's greater than 0.05. They believe that the proportion of all cars with this make and model with a defect is greater than 0.05, but really it's not. But the consequence here is going to be the same. Here I could say they don't think it's greater than the proportion of all cars of this make and model with a defect is not greater than 0.05, but really it was. so they don't take the case and they miss the money opportunity is what I wrote up down there. Okay.